Have you ever created a graph when you are trying to explore your data, whether it's about data analysis specific project or data science specific project? I hope that you already have done that using Matplotlib or Seaborn. But the problem is that when we try to create a graph using those specific modules, the graphs looks very static. They're not that much interactive. And that is where today's session is very important. Hi everyone, my name is Priya Bhatia, and in this specific discussion, I will be talking about in detail one of the very amazing module in Python, which is about Plotly Express. With the help of this tool, you will be able to create more interesting dashboards, more interactive dashboards, and you could have a lot of amazing features like hover, zoom, animations. So, without wasting any time, let's get started and we'll try to understand in a live implementation mode how basically this tool will actually work and how basically it is different from already available Matplotlib and Seaborn based tools. You might find the videos for Matplotlib and Seaborn in my Python playlist. This specific video will also be a part of Python playlist. I will try to attach the uh, previous videos where I have talked about, Seaborn and Matplotlib. And in this specific video, I will just give a simple illustration of how it will be different from those specific visualization tools that we usually use. Many people in the industries are aware about Matplotlib and Seaborn, but there are very few who are aware about this Plotly Express, and that's where this session is actually important. I really hope that you guys will enjoy this entire discussion. One thing which you have to make sure is that whatever implementations I am doing, please try to do it at your end as well, because the code things you will learn from implementation only, not by just watching the discussions. Also, please make sure that you will hit like button, share this video with everyone, and try to comment it down whether after learning from this entire video, have you ever aware about this specific tool or not? Have you ever used it in your work or not? And whether this complete discussion is actually helpful for you all or not, right? This will really means a lot to me. With that, let's get started. And over here, we will be discussing about another interesting, I would say, inbuilt library, or you can say module that we have, which we call as Plotly. Usually, when we talk about Python specific programming, we discussed in terms of visualization two main modules, and we already have discussed in this discussions as well. That is Matplotlib and Seaborn. Seaborn is kind of an advanced uh, updated version of Matplotlib, which actually helps us to create statistical based curve in a more easier way. And whenever we want to do a customization on that curve, for example, we want to change the figure size, we want to add the title, we want to, add the x-axis, y-axis namings. So in that case, Matplotlib is actually right now is beneficial. Now, when we talk about Plotly, it's basically providing us a dynamic, or in other words, I would say interactive plots. Interactive majorly means in our data science world, we will be able to make a story and explain to the clients or the stakeholders in a more better way. It means better storytelling, right? So over here, Plotly, you will see it's majorly used when you are trying to uh, create the dashboards. So when your main job is to showcase them the insights. So specifically the people who wants to enter into data analyst specific domain, they should know Plotly in a good way. Data science people, if they know, that's a good thing. If they don't know, it's completely okay. I mean, so in the dashboards, it's quite helpful to create the interactive dashboards. I'll showcase the difference between these two within few minutes. In the analytical tools also, we will use this Plotly. Okay. So over here, core idea is that we want to create a plot around figures, right? So over here, when we try to create matplotlib and seaborn based graphs, we have observed that they're kind of a static graph. And when we create a graph using Plotly, you will observe that they're kind of a dynamic graph, right? How they're dynamic and in what sense I am saying they're dynamic, I will just within few minutes will showcase you. So let's try to take one simple example. What I will do is I'll just open one collab. Um, this is the folder for today's session. Okay. Just like the share market graph, that's true. So what I will do is I will just try to open a Google Colab. Okay. Let's rename the file as Plotly in Python. We can connect this file. And first of all, obviously it's a module. So we need to import this module and we need to provide a I would say, alias name to it. So I will say import plotly.express. And inside that we have all the functions which we want to use. So as px is the alias name for this Plotly Express module. And inside this, let's say, first of all, I want to load data and I want to create a data frame of it. So what I will do, I will say data is equal to, I will say px dot. Now inside this, you have a lot of inbuilt data available inside this specific module. For example, let's say you want to load a iris data. I hope everybody have seen this iris data. सबको पता है ना iris data के बारे में. It's quite simple when we start the journey of ML or data science. These are the data sets which we commonly use to explain to the learners, right? देखा है सभी ने, पढ़ा है इसके बारे में. चलें आगे. Anyone who is not at all aware about this specific data set, please let me know. Otherwise, I think we can move ahead. You're not aware? So basically, when we talk about iris data set, so you can just have a look onto it. Basically, this contains, this is a data which is commonly used for visualization per se, to explain to the learners as a beginner that what different visuals that we have. In Matplotlib and Seaborn also, I think I have showcased the entire things using this. So this dataset contains 3 different types of irises: setosa, versicolor, and virginica. They have the petal and sepal length, and they're stored in 150 cross 4 dimensions. So you can see this is how its data looks like. So it's kind of a, you can say, multi-class classification problem where we will be having 3 categories of classes. These 3 colors, setosa, versicolor, and virginica. And in the given input data, we have the sepal length and sepal width. So you can see. Okay? Now let's go back to our main discussion. Okay. So if I will just try to showcase you how exactly this data looks like, so you can see. Can you see? Over here we have sepal length, sepal width, petal length, petal width, and then the species, which I was talking about. There could be 3 species. It's a data frame only. So if you want, you can also, I think, use a head function to have a look onto it. So you can see. So we have a species ID. We have a sepal length, sepal width, petal length, petal width, and the species corresponding to it. Is it fine? Just have a look onto maybe first 30 rows. Just let me know. Is this okay? So all of these are the setosa. That's why their species ID is 1. And these are the input features that we will be having. Chale aage. Shall we proceed further? Now, over here, let's say I just want to visualize this data using different plots. Now, I will ask you a quick question from you guys because I already have taken the discussion on visualizations in my previous part of the sessions. If, let's say, I want to see the relationship, if let's say I want to observe the relationship between two input features, which are, let's suppose, continuous in nature, So can you just let me know what specific plot is preferable in that scenario? So I have to understand the relationship between two input features, which are continuous in nature. So in that case, which specific plot will be beneficial? Irfan has mentioned scatter, Yuvraj mentioned line, Shaikh mentioned scatter. Exactly. So many people have mentioned about scatter plot, which is the correct answer. So scatter plot is beneficial whenever I want to examine the relationship between two input features, two variables. Specifically, those are continuous in nature. Now, when we talk about relationship, there could be, I would say, three possible scenarios. Either the two features are positively correlated, or the two features are negatively correlated, or there will be no correlation at all. Yes, we can use heat map as well. That's true. Positive means that if, let's say, you have feature F1 and feature F2. So you are saying that if my feature F1 is increasing, my feature F2 is also increasing. That is the literal intuition of positive correlation. Okay? Negatively means that if one of my feature is increasing, my another feature F2 is decreasing. And no correlation means there is no impact even if I increase or decrease feature F1 on F2. Okay? For example, over here in my case, I just want to examine the connection between this sepal length and sepal width. So what I will do is I will just definitely go with a scatter plot. अब हमने matplotlib and seaborn से भी उसको create किया होगा past discussions में. You can refer my recorded discussions as well. But today we will see that how can we create this via plotly. So I will say fig is equals to px dot scatter. Inside this, I will specify my data frame. I will specify what is there in my x-axis. So it is having a sepal width. I hope I have given the name in a correct way. Let me copy it otherwise. In the y-axis, we are providing the sepal length. And then I'm saying ki give the color to the different species that we will be having. Let's see what will happen. We are giving different color to the species because we could have three species, right? Let's see how it actually showcase to us. So we will say fig dot show and let's see. Hmm, interesting. Now, are you guys able to observe a difference between today's plot and the plots that we used to create in Matplotlib and Seaborn? Hmm. Anyone? Interactiveness. Now, for those people who are not able to recall it because it's been a lot of days, I'll create one plot where I can do a comparison, and then remaining you can do at your end. Okay. So for that, what we can do, we can say import matplotlib dot pyplot as plt, cbone as sns, and then we can say plt dot scatter, and again we can specify the same fields. What are the input features we want to specify? I'll just copy it exactly the same. So my x value is this sepal length, this sepal width, and any other thing which we have to specify. It's just that we have to take in the x-axis all the columns apart from species, because that is, I think, is a final outcome. So I'm just thinking ki whether we need to reload the data again or shall we do it from here itself. अभी के लिए इसी से करते हैं, फिर देखते हैं. तो x एक्सिस और y एक्सिस को डेटा से ही स्पेसिफाई कर देते हैं इंस्टेड ऑफ लोडिंग इट अगेन. तो वी कैन से कि इन द x एक्सिस आई वांट डेटा ऑफ सेपल लेंथ लिया था ना हमने, या विड्थ लिया है? x एक्सिस में क्या लिया था? विड्थ लिया है. सो वी कैन से आई जस्ट वांट टू लोड सेपल विड्थ, और y एक्सिस में भी हम डायरेक्टली डिफाइन कर देते हैं अभी के लिए, इट इज सेपल लेंथ. ठीक है. Then obviously we can define X label manually by saying, hey, this is nothing but a sepal width. We can define manually in the Y label also. ऐसे ही करते थे everyone. ऐसे ही create करते थे, कुछ miss किया मैंने? Sepal length. And then we used to provide the title in the matplotlib by saying, क्या लिखे? Iris scatter plot of sepal. ठीक है. एंड देन वी यूजुअली से plt डॉट शो. एक बार ट्राई करते हैं. कैन यू सी दिस स्पेसिफिक प्लॉट वर्सेस द अबव प्लॉट? what is the main difference? Now ठीक है, we can create a legend and based on that we can have different colors also, like the way we are having. The point is you will observe over here that it's too static. कुछ इंटरेक्टिव ग्राफ नहीं बना ऊपर नीचे वाले केस में. डिफरेंस समझ में आ रहा है कि हाउ that plotly graph are more interactive as comparable to the below one? Are you guys able to compare these two graphs or not? That's my question. So what is the core idea? I hope it is clear to everyone. Core idea is, so if we talk about the features of plotly specific graph, so we have seen that there are three important things which are happening over here. What are those? What are those? Interactive visuals. Second one. 3 चीजें आपको इस ग्राफ में दिख रही होंगी। क्या है वो 3 चीजें? ध्यान से देखो इस ग्राफ को। When you try to hover this, can you see इस ग्राफ में हमारे पास इंफॉर्मेशन आ रहा है हर एक डेटा पॉइंट का? Everyone. And by the way, I have not mentioned any single thing. I have just mentioned कि scatter plot create करके दे दो. That's it. So the first thing is the interactiveness. Second thing is the feature of this hover, where I will be able to see the entire information. Third thing is the legend. And I can just zoom in any specific legend by just doing a double click. समझ में आ रहा है? So once you will create it at your end, you will get to know better. Maybe I'll just share my collab to everyone. You can try at your end and play with this. You will get to know what I'm trying to convey over here. So what I'm saying is 3 interesting things are happening. So there is already a built-in interactivity in the plotly based plots, where you can see the feature of hover, you can see the feature of zoom, you can see the feature of legends in an automatic way. चलें आगे. Shall we move further? All good. Shall we move further? All good. थोड़ा सा आगे बढ़े. So till so far, we have just created a scatter plot. And we have understood that this plot will be helpful in the scenarios where we want to identify the relationship among two numeric slash continuous variables. Secondly, when we want to do a pattern detection part, when we want to identify, I mean, these two pointers are somehow interconnected. When we want to identify that how the two patterns in the given features are connected with each other, right? So let's move to the next plot now. So we have seen the benefits also. I hope it is clear to everyone. आगे बढ़े? आगे बढ़े everyone? Okay. Now, if let's say I just want to see a trend in a continuous data, so which specific plot should I use? I want to see a trend in a given data, whether it's going upward, downward, and so on. So which specific plot will be beneficial in that case? I'm talking about a trend, not a distribution. Again, I'm giving a quick hint. Line chart. So we have observed key Again, these things we already have discussed, so ideally everybody should know these things. When we want to identify the trends, whether it's a upward or a downward, that is where we preferably uh, go for that is where we preferably go for a line plot. Okay, so over here, maybe in order to create a line plot, what we can do is we can again identify, we can say px dot. Now, whatever be the plot you want to create, just write that name. Previously, we have created a scatter one, so we have written the name of that. Now we want to create a line plot, so we just have to written the name of the plot, px dot line. Then we have to mention our data. What do you want to create for? Maybe petal length. We can mention that. And finally, you can specify a title of your plot. Maybe you can say this plot indicates a petal length trend. And finally, we can just call a show function, which will help me to show this entire plot. So when we run this part, this is what you get to know. So you can see the trend, right, everyone? It's a creation of a simple line plot, I would say. So when to use? Just now we have covered up when to use. So the quick pointers are, first, when we want to identify the trends, upward or downward. Second, when we have a continuous data. And third important thing, when we are doing a time-based analysis. Clear है? All good? चलें आगे? All good, everyone? Shall we move ahead? Quickly, if you can give me a confirmation, clear or yes, then we can proceed further. And if you need some time, if you are creating a plot side by side with me, you can just let me know that as well. I will wait for a few minutes. So with that, we are done with the scatter plot. We have understood the intuition behind it. And we are also done with a line plot. Acha, what will happen when you want to compare any categorical entity with a continuous number? For example, over here, we have a species. Species is something which is a categorical entry because uh, there will be, you can say, 2 or 3 classes for that, right? And let's say this species, I want to compare the sepal length. So which specific plot will be beneficial for that? We have data, species dot value underscore counts. So you can see we have 3 classes, right, of species in this specific, I would say, data. It's Setosa, 50 records are there. Versicolor, 50 records are there. Virginica, 50 records are there. It means that in this entire data, we only have 150 records. Data dot shape. Huh. So we have 150 records. It's a very small data. Okay. And we just have a six features. Features we already have seen. Exactly. So, as already answered by many people, Deepak, Yuvraj, and Tenzin, you are not correct. It's not box plot. It's a bar plot or a bar chart, right, everyone? So, we have understood that whenever we want to compare a categorical entity, meaning any category, with respect to any continuous number, so in that case, we have something called as a bar plot, which will be beneficial, right? So, how can we create that? Again, same way. What you can do, you can just say fig is equals to px dot bar. You can specify your data frame. You can specify x-axis value, which is a species. You can specify y-axis value, which is a sepal length. You can specify the title of the plot, sepal length by species. And finally, you can say figure dot show. Amazing. See, that's the beauty of using a plotly. See, you can just hover on any specific part. It will just showcase you with respect to the individual species, uh, the comparison of a sepal length in a quick way. And we can see that, Virginica is the one which is having a higher sepal length, followed by versicolor, followed by Setosa. So in this way, we can do a category-wise comparison. So let me define over here. So we have talked about bar chart and when to use it. So first pointer, when we want a category-wise comparison. Second pointer, when we will be having a group of aggregated values. All good? चलें आगे? Give me a quick confirmation. Is this clear? Simple है? Simple, right, everyone? If let's suppose I want to look for a distribution of a sepal length. Listen the problem very carefully and then give me the answer. Creating the plots are not difficult in this case. It's just that we have not covered up this topic. That's why we're taking this session specifically. So you will enjoy only when you will answer these questions in an appropriate way. So if let's say I just want to see the distribution of the sepal length, which specific plot will be beneficial for me in that scenario? What do you think? Now it comes as histogram. So whenever someone is asking you, hey, can you create a histogram? Hint will be when to use it specifically. First part, where you want to do a distribution analysis. When you want to analyze a distribution. Second part, when you are saying that I want to look for the skewness, whether my column contains skewness or not. The skewness detection. That is where specifically maximum number of time histogram will be beneficial. So how can we create it? We can say fig is equals to px dot Again, write the function name, histogram. You can specify your data frame name. You can specify under which specific column you want to look for the distribution part. I want to look for a sepal length. You can specify how many number of bins you want. Maybe let's say 20. You can specify the title of your plot. You can say it's a distribution of sepal length. And finally, you can go for fig.show. As soon as you will say fig.show, you can see. तो कैसा distribution है ये? What is this distribution called as? What is this distribution called as? Um, right skewed बोल सकते हैं क्या? आई मीन यस राइट स्क्यूड ही बोला जाएगा बट इतना ज्यादा भी नहीं है. ये तो मैंने जूम कर दिया इसको. इट्स लाइक एक कर्व जा रहा है ऊपर की तरफ फिर करता करता नीचे की तरफ जा रहा है. तो राइट स्क्यूड वी कैन से या राइट स्क्यूड वी कैन से इट्स नॉट एक्सट्रीम एंड बट या नॉर्मल भी नहीं है लेफ्ट तो बिल्कुल भी नहीं है तो राइट में ही आएगा. लिटिल टुवर्ड्स राइट. या ऑल गुड. All good. Acha, when we have a skewed distribution, whether it's left skewed or right skewed, what does that indicate in a stats? What does that indicate in stats? Whenever we have a skewness, very good. Can we say that, when my data, so what we have understood over here, when we want to analyze the distribution of any specified column, we can call it as we can use I would say, a histogram, specific plot. Now, when we have a right skewed graph, something like this, where we have a peak on the left and then it is just going towards right side tail, or when we have a left skewed graph, something like that. In both the scenarios, in the right skewed scenario and in left skewed scenario, it indicates that we have a outliers availability. Yes, everyone? It indicates that we have a outliers availability. Yes or no? If I'll talk about, okay, if I'll ask you a question, first of all, what is the connection between mean, median, and mode when we talk about right skewed? So this is the highest frequency. This is something which we call it as a mode. And over here, this is the highest frequency. So we will call it as a mode. What is the mean? And what is the median? Median is the middle value. Mean is the average value. So can you just let me know in the right skewed how the value of mean, median, and mode is connected? And over here also. Can you just let me know? We have covered up again these things. Can we say in right skewed, median will be at the middle and followed by mean at the average end. So this is median and this is mean. And it will be sort of vice versa when we talk about a scenario of left skewed, because over here middle value is somewhere over here and mean value is somewhere over here. This is mean, this is median. So mode value is we can say lower, and over here mode value is somewhere higher. Yes, everyone, all good in both the scenarios? Now this indicates outliers, that's what we know, we already aware about this maths. Now how can we check this outlier? Which specific plot is specifically dedicated to check the outliers? Very good. So when we want to detect the outliers, we usually consider a plot of either box or a violin plot. Have you heard about violin plot? Anyone? Yes. Okay. So let's try to now create using this plotly in an interactive way a box plot. So maybe let's say I want to look for individual species in the x-axis, and in the y-axis I want to see the outliers availability in the petal length or maybe in the sepal length. Anyone you can try. So you can say fig, which is equals to px dot box, and inside this we can specify our data frame. We can specify under x-axis we have a species, in the y-axis we have let's say the petal length, and the title could be, you can specify as petal length distribution. And finally, oh, my data frame name is data, no? It's data. We can say fig dot show. So in which specific portion outlier is available? In which specific species outlier availability is there? Versicolor में you can see at the lower part, below lower whisker, and in the setosa also below lower whisker. In Virginica, it seems there is no outlier. So they're talking about upper fence and lower fence. It is also called as whisker, upper whisker and lower whisker. All good? चलें आगे? Yes, everyone. You will observe over here. Have we worked on machine learning specific algorithms in this batch? I don't remember it. Can you just confirm? No. Okay. Just let me see the curriculum of this batch. Okay, it will be after stats and EDA module. Okay. So you will observe in future ki when we see these kind of box plot, na, this actually indicates that there is a variation, and that too a very big variation in the scaling of the values when we compare with setosa versus versicolor versus virginica, है ना? क्योंकि आप देखो ना प्लॉट सिटोसा का कितना नीचे की तरफ आ रहा है, वर्सी कलर का इंटरमीडिएट पोर्शन में आ रहा है और वर्जिनिका का ऊपर वाले जोन में आ रहा है. तो स्केलिंग की अगर हम बात करें तो दे हैव अ डिफरेंट स्केल वैल्यूज. So you will observe in the upcoming modules when we try to learn about machine learning specific algorithms कि this is not a good practice. तो हम क्या करते हैं, हम usually outliers को handle करने से पहले भी एक काम करते हैं, वी ट्राई टू स्केल दीज वैल्यूज. हमें कोशिश ही रहती है कि सभी के सभी जो रीजन्स हैं या फिर सभी के सभी जो स्पीशीज हैं उनका स्केल एक ही हो ताकि मॉडल की बायसनेस ना हो. So we try to make sure that with the help of a standard scalar, yeah, standard scaling we do. And then if you will try to again recheck the box plot now, you will observe that every box plot will be of same scaled value. ऐसा नहीं दिखेगा आपको कि एक सबसे नीचे फिर बीच में फिर ऊपर. It's a very bad sort of uh, distribution because the scaling is completely different. नॉट श्योर कितना समझ में आया, बट अगर आया तो अच्छी बात है, नहीं आया तो मशीन लर्निंग में हम इसको कवर अप करेंगे स्पेसिफिक इशू को. ठीक है. ओके, लेट्स मूव फर्दर. Now, same thing you can analyze with the help of what we call as violin plot as well. तो सेम चीज रहती है. द ओनली थिंग इज यू विल कॉल डिफरेंट फंक्शन टू क्रिएट दैट. So let me just showcase you that as well. So you will say VIOILIN. Violin. You will specify data, species, petal length, violin plot distribution, and then you can see this. So you will observe in the violin plot also. If you will carefully observe it, सेटोसा के अंदर आपको एक छोटा सा डॉट दिखेगा. वर्सिकुलर के अंदर भी नीचे एक छोटा सा डॉट दिखेगा, एंड इसमें नहीं दिखेगा. तो बेसिकली दिस डॉट विच यू आर सीइंग ओवर हियर इज एक्चुअली एन आउटलायर, एंड इट्स द सेम आउटलायर which you can see over here. So you can hover and you can check these values are exactly same which we are observing over here. ठीक है. It's a way to interpret the violin plot. So this is how the outliers are visible inside this. ठीक है. All good. There is one parameter in the violin plot which we called as box. By default it is false. If you will make it true, see what will happen. You will be able to see a box plot inside a violin plot. It is also another amazing feature which can help you to analyze outlier in a more faster way. So अगर आपको violin और box का combination देखना है, तो you can make this parameter as true and you will be able to analyze it. Perfect? Perfect or not? But we do standard scaling only for clustering algorithms, right? No, it's not correct, Shaik. There are so many algorithms and supervised as well where we do standard scaling. Then there are tree-based algorithms where standard scaling is not required because those algorithms do internally itself. So it depends on what specific algorithm you are applying. But in a supervised learning also, in lot many cases, standard scaling is required in ADA. Okay? Perfect. Okay. Now there is another portion which is under this plotly, and we call it as a interactive sliders. I'll talk about this also. Maybe it might be required when you will be working in your firm as well. So you should have a knowledge about this. These interactive sliders will be helpful when you will be having a date specific column available in your data set. Have you guys at any point of time know about Excel tool or Power BI tool? Any one of them? क्या आप लोगों ने कभी काम किया एक्सेल पे या पावर बीआई पे टू क्रिएट द डैशबोर्ड्स ऑफ इट? Few people are saying yes, few people are saying no. If you have already done it, so I'm just giving you a reference. In the Excel, we have a feature in the slicers part, a timeline feature. I don't know how many of you have observed that. जहाँ पे ड्रैग करने का ऑप्शन होता है कि वी कैन एक्सटेंड, वी कैन इंक्रीज और डिक्रीज द टाइमलाइन एंड वी कैन सी अकॉर्डिंग टू द ग्राफ. So dynamically it will get changed. Similar sort of thing we can do this in this plotly as well. So let me showcase you one quick demo of this. So I'm just loading now the new data set. So I will say data frame df, which is equals to px dot data. ये भी inbuilt ही है. There is a data called as gap gap minder First of all, let me showcase you how this data frame looks like so that we will be having an idea about this data. So you can see in this data, we have a country name, we have a continent name, year, life experience, POP, GDP percentage cap, ISO alpha, ISO number. So now what I want is I want to create a visual of this data using the animations, using the animation frames, using the interactive sliders. Why I have chosen this data? Because in this data, I have one specific column which is based on the date specific part, which is year. So what I will do over here is I will say that, can you create a scatter plot of me? So see this very carefully. I'm creating a scatter plot where I'm just using my loaded data frame, DF. Oh, my bad. In the x-axis, I'm saying in the scatter plot, take GDP per capita. In the y-axis, I'm saying take life experience. In the size, I'm saying take pop value, population. I think it indicates. In the color part, I'm saying continent is the kind of a legend color portion. Now in the animation frame, that's the important feature which I want to define over here. I'm taking it as a year. So what will happen over here? That is something which I want to define you over here. When I run this, see the part very carefully. See the visual, how interactive it is. Now over here, see what happened. One thing you will observe, I have said log of x is equals to true. So it converts the x-axis value, which is GDP per capita, into a logarithmic scale instead of having a normal value. Why is that so? Few minutes back, I have talked about scaling. So what happens is there will be few countries where GDP value will be approximately equals to 500, 600 or 700. But then there could be some other countries where GDP value could be 50,000. So there is a very big range gap over here. So when we take a normal scale value, the plot will not give us a intuitive idea behind it. So instead of taking a exact value, we are saying take a logarithmic of this value. So this will be a very good way to handle the outliers in a given data. So that's why you will observe key values are very small in the GDP per capita. So now why it is called more interactive? Because you can see how the plots are changing with the year change. You can see how the data points are moving. And that's why in the starting of the session, I told you it showcases some sort of dynamic thing in our plots. Yes, every visual you can create using this plotly. All good? चलें आगे? Shall we move further? Similarly, if you want, maybe you can try at your end. I want you to create a visual for the x-axis. I want you to take x-axis as a continent and y-axis as a population. And I want you to compare based on every continent the population value using a feature of animation frames, which is equivalent to year. Which specific plot you will use for that? If we have these specific features to compare, think over it. थोड़ी देर पहले we have discussed about this visual as well. Just giving you a hint. Very good. Bar plot, because in the x-axis we will be having a category. In the y-axis we will be having a continuous entity, and I told you to compare that. Can you just do it for me, and then we can proceed further? Can you just compare, write a code, see the visual, and share the code with me? So it's quite simple. How can we do that? Again, we will try to say fig, which is equals to px dot bar. Inside this, we can specify our data frame. X-axis as continent, y-axis as population. We can specify the animation frame, which is our year column. The title, which will be equal to population growth over the time. And finally, we can go ahead and show this figure. So when we execute this, you can just have a look onto it, how the plots are changing in a dynamic way. समझ में आया? And that's the overall idea that we will be having for Plotly. I hope it is clear to everyone. Just give me a quick confirmation so that we can move to the next topic now, if it is clear.